Chapter 7, War Birds. African Americans carefully read every newspaper article about the Tuskegee Airmen, a group of Black military pilots who fought during World War II. As with any other flyers, their lives depended on knowing their plane's strengths and weaknesses and every response it would make as it waltzed through the sky. By the summer of 1944, the men of the 332nd Fighter Group were flying North American P-51 Mustangs. "It's best described as a pilot's airplane," said an American military official in a front-page article in the Washington Post. "It's very fast and handles beautifully at high speeds." With a big 4-blade propeller and a Rolls-Royce Merlin engine, the Mustang sped across the sky like a 400-mile-per-hour racehorse. The Tuskegee Airmen and lots of other pilots considered it to be the best plane in the world. "I will get you up in the air, let you do your job, and bring you back to Earth safely," promised the Mustang to its pilots, like a trusted horse to its rider. And helping the plane to make good on those promises was now part of Dorothy Vaughn's full-time job. Here's a picture of the Tuskegee Airmen in 1942 through 1943. Oh gosh. Well, oh my gosh. There it is. Oh. The secret weapon. But Dorothy couldn't really talk to her friends and family about her work. During World War II, the National Advisory Committee for Aeronautics wanted to defeat Germany by air, both by creating planes capable of destroying their targets and by coming up with technological advancements that would give the United States a military advantage. The Langley Laboratory was one of the United States' most powerful weapons, a secret weapon hidden in plain sight in a small Southern Virginia town. While the performance of the Mustang airplanes fighting overseas was a topic of front-page news, the daily work of the West computers and the others in the lab was considered sensitive and even secret. Bosses told their employees to stay on the lookout for spies disguised as soldiers or people who might try to get valuable information from laboratory employees. Air Scoop, the newspaper of the NACA, sounded the alarm. "You tell it to someone who repeats it to someone, so someone you know may die." The Langley employees took the warning to heart. Even if they wanted to talk about their work, they would have found it difficult to find someone outside of the lab who would understand what they were talking about. Off campus, people from around town often found the Langley employees a bit peculiar. They had strange accents from other parts of the country. Many of them wore rumpled shirts with no ties, and some wore sandals or sported beards. Locals called them brainbusters, or NACA nuts. The less polite called them weirdos. Make what makes them fly. The pace of discovery and invention was so fast at Langley that an entry-level position there was considered by many people to be like studying at the world's best engineering school. In addition to receiving on-the-job training, employees had the chance to take classes in math and physics and other subjects that would help them further understand how to design better planes. And that's what Dorothy did. With the goal of turning women's math teachers into crack junior engineers, the laboratory sponsored a crash course in engineering physics for the newly arrived computers. 2 days a week after work, Dorothy Vaughan and the other new mathematicians filed into a makeshift classroom at the laboratory for an intensive class in the fundamental theory of aeronautics, which is the study of objects moving through the air. They also attended a weekly 2-hour laboratory session for hands-on training in one of the wind tunnels, and they had an average of 4 hours of homework on top of their 6-day work week. What makes things fly? Dorothy asked herself all day long at her new job. She had never flown on a plane and had never before given much thought to the question. The first course she took at Langley taught her the basics of aerodynamics. She learned that when a wing moves through the air gets cut into 2 parts. There is a slow-moving airflow on the bottom of the wing and fast-moving airflow on top. This creates 2 different pressures, and it's this difference in pressures that creates lift. the most magical force that causes the wing and the plane attached to it to rise into the sky. It's important to keep air smoothly flowing around the plane. Turbulence or sudden gust of wind may make a plane hard to control. One of the NACA's greatest achievements was designing wings that allowed planes to move easily through the air. Today, we take many of these design elements for granted, but each change came after a series of experiments in mathematical computations and luck. The first inventors made some assumptions, built a plane, tried to fly it, and if they didn't die in the process, they applied what they learned to the next attempt. By the time Dorothy was on the job, the task of modifying airplane designs had been turned over to the aeronautical engineers and the test pilots who flew the planes directly into their weak spots. Each time the pilots pushed the aircraft to the limit, they helped generate data that could be used to identify ways to make a good plane even better. The test pilots also risked their lives and the loss of a very expensive piece of equipment. To make the job easier, researchers developed wind tunnels that allowed them to test model planes without the danger of flying a real plane. At its simplest, a wind tunnel was a big box attached to a powerful fan. The basic idea behind the wind tunnel was that air moving at a certain speed over a stationary object was similar to moving the object through the air at the same speed. Engineers blasted air over full-size aircraft scale models or individual parts, such as wings or bodies. By closely observing how the air flowed around the object, the engineers could assess how the objects would fly through the air. Langley built different wind tunnels to test specific features of the planes. There was even a tunnel called a full-scale tunnel, which opened wide enough to swallow a full-size plane. Running the electricity-hungry wind tunnels wasn't always easy for the laboratory, because the local power companies rationed electricity during the war, including for the laboratory. The NACA solved the problem by running some of their tests into the wee hours, and people living near Langley complained about the roar of the tunnels while they were trying to sleep. Despite the challenges, building wind tunnels there were quite similar to real-world conditions, and it was one of the keys to the NACA's success, making a good plane better. No organization came close to Langley in the quality and range of wind tunnels research data. It wasn't good enough to say a plane flew well or badly. Engineers tried to measure how a plane performed, so they developed a 9-page checklist. These experiments generated data, numbers, lots and lots of numbers. And the raw data from the test then went to the desk of Dorothy Vaughan and the other female computer analyst. An airplane wasn't one machine for a single purpose. It was a complex machine that could be tweaked to perform different kinds of tasks. The airplane names or designations reflected their uses. Fighters, also called pursuit planes, were assigned the letter F or the letter P. The letter C is identified cargo planes, which was built to transport military goods and troops. B was for bombers, and X marked the spot of the experimental planes still in development. Planes lost their X designation once they went into production. For example, the B-29 was the final version of the XB-29. Engineers worked hard to make each version of an aircraft better and more stable than the previous one. Discoveries large and small contributed to the speed, maneuverability, and safety of the machines. As World War II approached its peak in 1945, almost every American military airplane being produced in factories had features that were based on the research results and recommendations of the NACA. And here's a picture of a B-29 Super Fortress. It was a 4-engine propeller-driven heavy bomber used during World War II. It was the most expensive aircraft designed during the war. Fun fact, my grandfather flew the B-52 bomber, and he is currently tied with another pilot for the most hours spent in a B-52 bomber airplane, and he helped fly during the Korean War and Vietnam War. So, fun fact. His name is Harold M. Rigg, R-I-G-G. Okay, Whether data came from the wind tunnels, test flights, or theoretical models, it eventually reached the women computers so they could use their sharp pencils and sharp minds to figure out what the numbers meant. Instead of looking at just a few numbers, they looked at extremely large sets of numbers, which could be used to find patterns or trends in the ways the airplanes performed. What Dorothy and the other women at the laboratory worked on was usually a small portion of a larger task. The work was carved up into smaller pieces for quick, efficient, and accurate processing. By the time the work arrived on the computer's desk, it might be just a set of equations and numbers. Sometimes they didn't even know what kind of plane had been tested or what the engineers were hoping to understand from their research. Once a woman finished a particular job, the calculations were taken to the engineers, who used them to improve airplane designs. The computer's work was essential but largely uncelebrated. "Woe unto thee if they shall make thee a computer," joked a column in Air Scoop. "For the project engineer will take credit for whatsoever thou doth that is clever and full of glory. But if he splendeth up and maketh the wrong calculation, he shall lay the mistake at thy door when he is called to account, and he shall say, 'What can you expect from girl computers anyway?'" But sometimes the breakthrough was so important that everyone got credit. When the Boeing B-29 Super Fortresses was finished, it became a symbol of the United States' technological progress and its ability to bring destruction onto its enemies. There was no one in the laboratory who shall feel that he or she did not have a part in the bombing of Japan. The NACA director said to its lab employees, "The engineers who assisted, the mechanics and model makers who did their share, the computers who worked up the data, the secretaries who typed and retyped the results, the janitors and maids who kept the tunnel clean and suitable for work, all made their contributions to the final bombing in Japan." Dorothy knew that her work was making a difference in the outcome of the war. She read the news accounts on how the B-29s, capable of flying farther, faster, and with a heavier bomb load than any plane in history, dropped precision bombs over Japan from high in the sky. Dorothy found her work more intense and interesting than she had imagined. And she knew she wanted to stay for the duration of the war, and maybe longer. There was no doubt about it. Dorothy Vaughan had become one of the NACA nuts. Chapter 8, The Duration. Though Dorothy Vaughan loved her new job in Hampton and was proud to be helping her country with the war effort, she missed her children terribly. She sometimes worked 18-hour days, and the demands of her job made it difficult for her to get home except for during holidays. And it seemed like the minute she walked through the door at the family house back in Farmville, it was time for her to return and head back to Newport News. When she could go home, the back and forth lifestyle was taking a toll. Dorothy wanted something more permanent. Like most of the computers at the Langley Memorial Aeronautical Laboratory, Dorothy was a temporary war service employee. She didn't know when or if the laboratory would offer her a permanent job. Dorothy knew what she wanted her future to look like, so in July of 1944, she signed a lease on a new 2-bedroom apartment in Newsom Park. Dorothy wanted her children eventually to live with her for good in Newport News. This 2-bedroom apartment would be a start. But finding the right house wasn't easy. There weren't enough homes available to meet the demands of the growing African American population. Dorothy chose a neighborhood near where she had been living for the previous 9 months. It included Black families from all income levels. Domestic workers lived next to the doctors, lawyers next to the laborers, small business owners next to civil servant mathematicians. All were welcome. Dorothy's new home was identical to the 1,199 others that had been built in the same subdivision. Newsom Park was also designed to keep morale high among the wartime workers who had to work long hours under stressful conditions. The Newsom Park residents loved that their neighborhood had a community center with a kitchen, a banquet space, rooms for club meetings, and basketball and tennis courts. They even had a baseball diamond. And the shopping center included a grocery store, drugstore, barbershop, beauty parlor, cleaners, and a TV repair shop. A nursery school and a new elementary school were in the walking distance from her apartment. Dorothy's mother-in-law tried to discourage the move. "You're not going to take my babies," she said to Dorothy. Dorothy appreciated her mother-in-law's help all those months she'd been away, but now she needed her children to be close to her. A year after Dorothy left Farmville, her children moved into the apartment in Newsom Park. They started at Newsom Park Elementary School in the fall of 1944. Her husband continued to travel with his job as a bellman. He came down to visit when he could, but he didn't stay long. Victory over Japan. By 1945, 5 out of 10 people in southeastern Virginia worked for the government. Housing development sprawled for miles. The community was built around the business of war, but people were starting to wonder what a defense industry boomtown would become during a time of peace. The answer came on VJ Day, Victory over Japan Day. On August 14, 1945, at 7 p.m., newscasters announced that World War II was over. All over town, soldiers and civilians streamed into the streets. Business owners locked their doors and joined the celebrations that went on through the night. People paraded down the streets, and workers held hands to form human chains as they danced around cars. Makeshift confetti rained down from windows onto the streets below. But after the initial celebrations and parties, uncertainty settled in. 3 weeks after VJ, the Norfolk Journal and Guide reported layoffs of 1,500 Newport News shipyard workers and a decrease for women workers, both white and colored. Returning servicemen were expected to have first claim on the jobs that remained in the peacetime economy. With the return of the men who had been fighting overseas, the demand for women workers dropped. 2 million American women, black and white alike, received pink slips, or notices that they were losing their jobs, even before the war officially ended. Some women looked forward to going home. Others enjoyed their jobs and their paychecks, and they didn't want to go back to the traditional female roles in the kitchen and nursery. Many husbands will return home to find that the helpless little wives they left behind have become grown, independent women, wrote a female columnist in the Norfolk Journal and Guide. Post-war prejudice. Almost immediately after VJ Day, some employers returned to their policies of not hiring African Americans. With the labor market changing, the dream that many Black leaders had of establishing permanent economic opportunity began to slip away. No one was more opposed to opening hiring policies to African Americans than Virginia's Democratic Senator Harry Byrd, who called the policy the most dangerous idea ever seriously considered. Byrd's family had built a newspaper and apple-growing fortune, and he treated segregation as a religion. He ran a political machine that kept the poor of all races divided against one another. This is a picture of Harry F. Byrd. He was a white supremacist who favored racial segregation. Boo. Dorothy, like so many of the others who had come to Hampton Roads during the war, didn't want to return to her former life. She assumed that she was going to keep her job and continue with her new life. It wasn't a risk-free bet. Dorothy committed to the lease on the apartment in Newsom Park before Langley converted her wartime employee status to that of a permanent civil service employee. She didn't want to wait to put down roots in her new home, even though it soon became apparent that losing the apartment was still a possibility. Dorothy and the others who lived in her neighborhood learned that some local officials wanted to demolish Newsom Park and develop the neighborhood. Federal authorities planned to pry the houses off their foundations and send them to war-devastated populations in Europe. The residents went back and forth with the government over the status of their neighborhood, which they had come to love. The government said that Newsom Park was not temporary in character and yet not permanent in its current location. Though they lived in a state of limbo, the people of Newsom Park were determined to do everything they could to keep their community alive. Life in Newport News was an adjustment for Dorothy's children, who missed their small town freedom and the space at the big house in Farmville. But as the months passed, The family settled in. Dorothy had become quite closer to her fellow West Computer Marion man. They were friends both at work and at home, and their families had become like one large extended family. When Dorothy and Marion learned that the famous African American singer Marian Anderson was going to perform at Hampton Institute, the women made plans for their families to go together. On the day of the performance, Dorothy looked over at her children, who were entranced by Anderson's beautiful voice. Dorothy knew this moment was one her family would never forget. She knew they were home.